to solve few problems based on equilibrium of beams, and then we are going to march ahead. So let us look at the first problem. So here you have supported beam. So on one side you have a hinge support, on another side you have a roller support, and it is loaded with uniformly distributed load or rectangular load of intensity 300 pounds per feet over the entire length. And then you have an arm CD, for to which at D there is a point load of 300 pounds, and the distances between points A, D, and B have been given. Are you with me, Chaitanya?
Yes, sir.
Yes. So now what? How are we going to do? How are we going to find out reactions? The question is find out reactions at A and B. So what kind of support A is? Chaitanya, tell me what kind of support is A?
Sir,
Chaitanya?
point support.
No, we have discussed three types of supports: hinged, roller, and fixed support. What kind of support is
It
A?
is a fixed support.
No, it is a hinge support. Where you were absent for first few lectures.
In one,
Pardon?
I was in one lecture, sir.
You have?
In one lecture, I was absent.
No, but we have at par discussed this support many lectures back. So you should have gone through and seen the video. If not, now do it. Now A is a hinge support and B is what kind of support? It is roller support. So how many reactions do prevail at A, Chaitanya?
One.
No. At hinge support, you have two reactions and those are force reactions. How many reactions do prevail at B?
Again, two, sir.
No, at B there is only one reaction because it is roller support. I can now understand that you have not gone through the lecture seriously. So you can mute. I want now Omkar to unmute himself. Omkar. Omkar Sangrulkar. I have sent you the request to unmute. So accept it and unmute. Yeah.
Yes, sir.
So at A you have two reactions and at B you have one reaction. Do you agree with me?
Yes, sir.
Okay. So let us draw free body diagram of beam ACB.
Okay, sir.
So let me draw the free body diagram. This is point A, this is point C, and this is point B. Now, how many reactions? Free the body from all external agencies and show what the external agencies were doing. So, how many reactions do prevail at B?
Sir, at B only one reaction.
Yes. So, I will show that as this one, force reaction. Do you agree with me? And I'm going to call it as RB. Happy?
Yes, sir. Yes, sir.
And how many reactions at A?
Sir, two reactions.
Yes. So, one of them is going to be vertical reaction VA. Students are still joining. As I have said, I have not started that, but from tomorrow after 10 minutes I am going to lock the classroom, so be careful. You have to be in within 10 minutes from the starting time. Now at A you also have horizontal reaction, and that is HA. Are you with me?
Yes, sir. Yes, sir.
Okay. And then we have a uniformly distributed load, which I said in the previous class we can also denote by this notation, and its intensity is 300 pounds per feet. Are you with me?
Yes. Yes, sir.
Now tell me, should I show its self-weight or not?
What, sir?
Self-weight of the beam.
No, sir.
Okay. Because nothing is mentioned about it in the problem, therefore we have to neglect the self-weight. Otherwise we would have shown the self-weight. Do you agree with me?
Yes, sir.
Yeah. Somebody please inform Sujesh Sawant on the group that he has not added his roll number, so I am not going to let him in. So add the roll number and then I will allow. Now let us go ahead. What we should also have shown a arm here from C to D, and I should show this 300 lb. But now I am drawing free body diagram of only ACB. Do you agree with me? So what is
Yes,
the
sir.
effect of this 300 pounds at C? That's what I am interested in. So kaise karna hai? In first few classes we have discussed about effect of a force acting at a point on other point on the body. So what is the effect? You have force as it is. So ये 300 pounds का force as it is C पे दिखाना है. Do you agree with me?
Yes, sir.
And in addition to that, we also have a moment. Are you with me? Moment
sir.
कैसे calculate करना है? 300 into 2 feet. And at C, it is anti-clockwise in nature. Do you agree with me? ऐसे जाएगा anti-clockwise.
Yes, sir. Yes, sir.
So that moment, I am going to show it here. And that moment is how much? It has a magnitude of 300 into 2.
600.
Yes, 600 feet is the unit. Are you with me?
Yes, sir. Yes, sir.
And now this free body diagram is yet not complete because I have not shown the distances. So this is 4 feet. And what is the distance between point C and B? It is also 4.
2 feet.
No, between
sorry.
C and B, it is 4 feet. So what is the crux of this problem? Crux of this problem is you have to understand that if there is a force acting at D, its effect at C is going to be a force couple system. And as I am drawing the free body diagram, yeah, go ahead.
Sir, it is given that the point D is 4 feet from A.
Yes, you were right. It is 2 feet.
Sir, so distance should be 6 and 2.
Yes, you are right. Perfect. So I made a mistake here. That's correct. This distance is 6 feet and this distance is 2 feet. So what is the crux of this problem? Crux is to understand that if at D you have 300-pound force, its effect at C is going to be not only the force but also the moment. Are you with me? So you have to transfer, and we are drawing free body diagram of beam ACB. Therefore, we are not showing that arm. So if the arm is not shown, but that arm is connected at C, so what that arm must be doing at C? So it must be pulling beam ACB down by 300-pound force, and it must be trying to rotate point C in anti-clockwise sense by moment 300 into 2. Are you with me?
Yes, sir. Yes, sir. Yes, sir.
Yeah. Okay. So this free body diagram now is complete. So how do we go about next? Means what should we do next? Next is application of equations of equilibrium. Do you agree with me?
Yes, sir.
So the first equation is summation fx equal to 0. That is going to give me HA equal to 0.
Yes, sir.
Are you with me?
Yes, sir.
Because summation fx is 0, there is no other force than HA. That implies HA is equal to 0. Happy?
Yes, sir. Yes, sir.
Now, if I use summation Fy equal to 0, there will be two unknowns that will be popping in, VA and RB. Do you agree with me? So it is not wise to use this equation first. First, we will use summation of moments about A or B equal to 0. So let me choose summation of moments of all the forces about z-axis passing through point A is equal to 0. Are you with me?
Yes, sir.
What is the moment of HA and VA? Moment of HA and VA is nothing because it passes through A itself. Do you agree with me?
Yes, sir. Yes, sir.
What is the moment of this force generated due to UDL? तो इस UDL को हमें रिप्लेस करना पड़ेगा. Are you with me? तो कैसे रिप्लेस करना है? इसके अंडर का एरिया. So what is the area? So I am going to replace this UDL by a point load. What is the area? 300 multiplied by 8 feet. Do you agree with me?
Yes, sir.
And where is the centroid of this rectangle? Centroid of this rectangle is at 4 feet. So this distance is 4 feet. Do you agree with me?
Yes, sir.
So now in this free body diagram, don't look at this UDL. Just look at a point load which is placed at distance 4 feet from A. So what will be its moment? 300 into 8 into 4. But it will be in clockwise direction about it. Do you agree with me?
Yes, sir.
Therefore, I am going to write this as minus 300 into 8. 300 into 8. Are you with me? Multiplied by 4. Happy? So this is clockwise. Now what else? There is a 300-pound force sitting at distance 6 feet. Do you agree with me?
Yes, sir.
What is its moment now? 300 multiplied by 6. It is also clockwise. Do you agree with me?
Yes, sir.
So that I have written 300 minus 6. I'm I have increased my speed because we have done this now numerous times. So you will be able to understand this quickly. There should be no issue. Now, what about the moment of 300 into 2? So as we have already discussed, the couple moment can be transposed anywhere in its plane. So even if it is acting at C, its effect at A is same. So therefore, this couple
sir.
moment anti-clockwise, I have to take as it is. And as it is anti-clockwise, I am going to take it as plus. So 300 into 2. Do you agree with me?
Yes, sir.
Most common mistake, people tend to multiply this couple moment by distance 6 feet. That's not correct. You have to understand this already is force multiplied by distance. This already moment itself. Are you with me?
Yes, sir. Yes, sir.
So we should not multiply it with distance. Only forces are to be multiplied by perpendicular distance to get the moment.
Yes,
are you
sir.
with me? Okay.
Yes, sir.
Now which force is remaining? RB. So what is the moment of RB about A? RB into 8 feet. And is it anti-clockwise? Is it anti-clockwise?
Yes, sir.
So I will write it as plus RB into 8. Happy? Have we considered all the moments?
Yes, sir.
So this is equal to 0. Now Chaitanya, solve this and tell me what is the value of RB. Yes, have you solved, Chaitanya?
Sir, it is 1,350.
1,350. Others also should give a check on calculation, but I will accept as it is now. Others should give the check. So this is found and it has turned out to be positive. Do you agree with me?
Yes, sir.
Okay. So if it has turned out to be positive, then that means originally assumed sense of RB is correct. Are you with me?
Yes, sir.
Therefore, it is upward. So RB we have found out. Now, how do we found out VA? By summation Fy equal to 0. Happy?
Yes, sir. Yes, sir.
So when I do summation Fy equal to 0, what are the forces? So I have to look at free body diagram. So HA is not, it doesn't have any vertical component. So VA is vertical itself. So therefore plus VA, because I have assumed it to be upward. Do you agree with me?
Yes, sir.
Then this 300, so minus 300, because it is acting in negative Y direction. Happy?
Yes, sir. Yes, sir.
And now next is the effect of this UDL. Again, Sujay Sawant, I don't know why he is joining without roll number. So ask him to join with roll number. Please, someone ask him. So now minus 300, VA minus 300. And then what is the effect of this UDL? So its effect of UDL is this much point load. Do you agree with me?
Yes, sir.
And it is acting in downward direction. So I am going to write it as minus 300 into 8. Are you with me?
Yes, sir.
And one more force, that is RB. So plus RB.
Yes, sir.
Happy? Yes.
Yes, sir.
And what about this moment? Moment cannot be added to forces. Apples cannot be added to oranges. Only the quantities which have same units can be added amongst one another. Do you agree with me? So moment is not to be considered in summation Fy equal to 0. Are you with me?
Yes, sir.
So this has to be equal to 0. Now out of that, what is the value of RB? RB we have already found it to be plus 1350.
Yes, sir.
So substitute it and tell me what is the value of VA.
Sir, minus 1350.
Minus 1350.
50.
No, I don't think so. It should be minus. Why should it be minus? No.
Sir, I will check on
check it. There is some problem, or otherwise the value of RB is incorrect. So let me calculate the value of RB. So it is 300 into 8 into 4 plus 300 into 6 minus 300 into 2. 10800 divided by 8. The RB is correct. 1350, that's right. 300 into 8, that is 2400, plus 300 2700, no, minus 1350. No, we are getting, I am getting VA as 1350 itself. Chaitanya?
Yes, sir. Yes, sir. Sorry, my mistake, sir.
So 1350 pounds. So VA is equal to 1350 pounds, and it is also positive. Therefore, it has to act upward. Do you agree with me?
Yes, sir.
Are you with me?
Yes, sir. Yes, sir.
Okay. So we have found out all the reactions at A and B. This was about the first problem. Now quickly, so what was the crux of first problem? Crux of first problem was reducing this 300 pounds at C by a force coupled system, and identifying that the equivalent point load corresponding to this UDL is 300 into 8, and it acts at the centroid of the rectangle. Do you agree with me?
Yes, sir.
Okay. Now the next type of beam. Tell me what kind of support is there at A? Chaitanya. No, not Chaitanya. Who was speaking right now?
Sir, I was speaking.
What is name?
Sir, my name is Omkar.
Omkar. I'm sorry. So Omkar, what kind of support is there at A? This is, as we have seen, this is the typical notation of fixed support. इसको क्या बोलते हैं?
Fixed support.
So this is fixed support. So what kind of reactions does a 2D fixed support offer? It offers two force reactions and one moment reaction. Do you agree with me?
Yes, sir.
And that moment reaction will be about Z axis. I am going to consider this as X. If I don't say henceforth which is X, which is Y, and which is Z, then you have to understand that I am assuming that this is X, this is Y, vertical is Y, and Z is coming out of the plane of both, unless I specify otherwise. Are you with me?
Yes, sir.
Chalo. Now let us draw the free body diagram of this beam AB. This is called as cantilever beam. The other end is free. There is no support at B, and there is support only at A, and that support is fixed end. So therefore we call this beam as cantilever beam. Are you with me?
Yes, sir.
So what is the name? Cantilever beam. Now let me draw the free body diagram of AB, FBD of beam AB. So सबसे पहले क्या करना पड़ेगा? I need to free beam AB from all external agencies, which includes Earth. But there is no data about the self-weight of the beam is given, so I am not going to show the self-weight. Are you with me?
Yes, sir.
Then at A, I can have three reactions because it is fixed support. One is VA, another reaction is HA. Are you with me?
Yes, sir. Yes, sir.
Third reaction is going to be moment reaction about Z axis passing through A, and I am assuming it to be anti-clockwise. I assume it to be anti-clockwise. So therefore, I am going to call this reaction as MA. So what is MA? It is the moment reaction that a fixed support can offer at this point. Happy?
Yes, sir.
Okay. Now, This is uniformly varying load. We have discussed this in the last class. Do you remember?
Yes, sir.
And it is 120 pounds per feet is the load. Intensity at this end. Intensity at this end, load intensity at this end is 0. Happy?
Yes, sir.
This is 6 feet and this is 6 feet. So total length of the beam is 12 feet. Are you with me?
Yes, sir.
Now, what is the equivalent FPD? I have to replace this UVL by a single force. तो कैसे करना पड़ेगा? So I am going to have VA here. Are you with me? You are going to have HA here.
Yes, sir.
And you are going to have MA here. This is the moment reaction that can be offered by the fixed support. Happy?
Yes, sir. Yes, sir.
And we are going to have a point load corresponding to this UVL. What is the value of this point load? So it is going to be area under this triangular load.
Yes, sir.
So half multiplied by 120 multiplied by 6. Agree?
Yes, sir.
And where does it act? It acts at the centroid of this triangle. Where does the centroid of this triangle lie from free end? 2/3 of 6. Do you agree with me? From
Yes, sir.
vertex, it is 2/3 of 6. So what is 2/3 of 6? So it is at 4 feet. Do you agree with me?
Yes, sir.
So this distance is 4 feet where this point load acts. And so therefore, what will be this distance? Total distance is 12. 12 minus 4. So this distance must be 8 feet.
Yes, sir.
Are you with me? This is the crux. So you have to replace uniformly varying load by a single point load by computing the area, and it acts at the centroid of this triangular area. Are you with me?
Yes, sir. Yes. Yes, sir.
Okay. So now again we have 3 unknowns and 3 equations. Summation fx equal to 0 is the first equation that we are going to apply. That is going to give me what? That implies
Sir, HA.
HA has to be equal to 0. Are you?
Yes, sir. Yes, sir.
Okay. Now, what is the next equation that I should use? Now, if I use moment equation, then MA is going to pop in. Do you agree with me?
Yes, sir.
So we are not going to use moment equation because MA, if I use moment equation, no, still we can use by taking moment about A. So HA and VA के कुछ भी moment नहीं रहेंगे, only MA will prevail, and therefore I will directly be able to find out MA. Are you with me?
Yes, sir. Yes, sir.
So summation of moments of all the forces about Z axis passing through A is equal to 0 is the equation that I am going to use. So tell me, what is the moment of HA and VA? Nothing. What is the moment of MA itself? It is MA itself and it is anti-clockwise. So I am going to take it as positive. Do you agree with me?
Yes, sir.
So plus MA, this is already a moment. It is not a force. So there is no question of multiplying it by distance 0. Therefore, it has to be MA itself. And what is the moment of this force? It is clockwise. And what is the amount? Minus half multiplied by 120 multiplied by 6 multiplied by 8. Do you agree with me?
Yes, sir.
And clockwise, therefore, I have to give the sign as minus. So what is the value of MA? Tell me. MA will be equal to? Yeah.
Sir, 2880.
2880. And what will be the unit? The unit of MA will be pound feet.
Yes, sir.
Okay. So this is 2880. Now, Omkar, you can mute yourself. I want now Chaturthi to unmute herself. Chaturthi Pardeshi. I have sent you the request to unmute. Accept it.
Yes, sir.
Yes. So MA is equal to 2880 pound per feet, and it has turned out to be positive. What is its meaning?
So the assumed sense is right.
Yes. So assumed sense was anti-clockwise, so it must be anti-clockwise.
Yes.
Chalo.
Yes,
What
sir.
is the next thing that we are going to do now? We are going to do summation Fy equal to 0. Happy?
Yes, sir.
Now tell me summation fy equal to 0 में क्या क्या आने वाला है?
Summation. So
Va.
yes.
So plus Va. Okay. Will there be any contribution of Ha?
No.
No. Will there be any contribution of Ma?
No.
No. So will there be the contribution of this force? Yes, of course. So that is going to be
Yes.
minus half
Half
into
into
120
120 into 6.
Right. So minus half into 120 into 6. This must be equal to 0.
0.
That gives V. Va is equal to how much?
360.
360. So answer has turned out to be positive. Therefore, originally assumed sense of Va is correct. And originally assumed
Upwards.
sense is upwards.
Yes.
So therefore it is upward. देखो आंसर में क्या क्या चीजें आपकी देखी जाएगी. You must specify this plus sign. You must specify this magnitude. You must specify the system of units in which you have found out the answer, and you must infer from the positive sign the originally assumed sense is correct, and therefore you must show the direction. इसमें से कोई भी एक चीज missing है, so that means the answer is not complete. Are you with me?
Yes. Yes.
Okay. Chalo. Now let us go to the next problem. Next problem is very interesting. Next two problems are very interesting problems. Can you read it for me, Chaturthi?
The beam is subjected to the distributed load and the couple shown. If M is slowly increased starting from 0, at what value of M naught will contact at B change from the lower surface to the upper surface?
And now forget about this M naught because they have called it as M. So there should be no confusion. At what value of M the contact will change from lower surface to upper surface is what is being asked. Are you with me?
Yes.
So now how are we going to solve this problem? This is tricky problem. You have to understand the concept and then it is easy. First thing that we are going to do is we are going to draw free body diagram. Are you with me?
Yes.
So I draw free body diagram of beam AB. What all should be shown? So what kind of support is A? Chaturthi, tell me.
So it is hinge support.
Yes, it is hinge support and therefore it is going to have two reactions.
Yes.
One is Va and another is HA.
HA.
You agree with me?
Yes.
What kind of support B is?
So double roller support.
Yes, so we have discussed it in the beginning. It is double roller support. But right now we will assume that only the roller below is in action.
Action, huh?
Are you with me? That means the beam is touching the lower surface. Are you with me?
Yes.
That's what we assume. That is our assumption. So in that case, what kind of reaction can be offered? Only upward reaction can be offered.
Yes.
So I assume that lower roller is active. Are you with me?
Yes, sir.
Is active. Then it can offer only upward reaction.
Yes.
So RB. Now I am now going to switch the gear. We are going to go a little fast. I am not going to show this triangular load. देखो यहाँ पे एक triangular load है ना?
Yes.
And then there is a UDL. Rectangular load. Instead of that, I am directly going to show the two corresponding point loads. So what is the point load corresponding to this triangular load? Can you tell me? Area under this triangular load?
So it is 2/3 of yes, half into 400.
Half, yes, half into 3 into 400. Do you agree with me?
Yes.
And where does it act? It acts at the distance 2/3 of 3 from this point. Do you agree with me?
Yes, sir.
So what is 2/3 of 3? 2. So it is going. So this distance is going to be 2 feet. Are you with me?
Yes, sir.
2 feet. Now, what about this rectangular load? What is the corresponding area?
400 into 3.
400 into 3. And where does it act?
At the center
point. So it is going to act at a distance of 1.5 from here. Do you agree with me? So therefore this distance I have shown it as 1.5 feet. Happy?
Yes, sir.
then there is a moment M which is to be evaluated. Are you with me?
Yes, sir.
So I am going to call this as M. Happy?
Yes, sir.
Huh. So is this free body diagram complete? Not yet, because I
No,
have
sir.
not shown these distances, 3 feet and 3 feet. Self weight is not to be shown because nothing is mentioned about the self weight of beam. Happy?
Yes, sir.
And now I have to find out the moment at which the contact at B will change from lower surface to upper surface as I go on increasing M. Do you agree with me?
Yes, sir.
हाँ, तो अब जरा देखो M का नेचर कैसा है. M is trying to lift support B and it is trying to press support A. Do you agree with me?
Yes, sir.
It is trying to force this support A down and it is trying to lift this support B. So due to this downward loads, there is going to be some RB. That RB will be decreased as I go on increasing M. Do you agree with me?
Yes, sir.
So on the verge, when the reaction RB, lower roller support is going to become inactive and upper roller support will come in force, at that time,
Yeah.
what will be the value of RB? 0?
Yes, sir.
So as I go on increasing M successively, RB goes on reducing, and for particular value of M, the RB is reversed. That means RB will be acting down in downward direction. Upper roller will come in picture. Are you with
Yes,
me?
sir.
So at the boundary of these two, when the end B of the beam is about to lose the contact with lower roller and it is about to gain the contact with upper roller, RB is going to be 0. Do you agree with me?
Yes, sir.
So I have equated this RB equal to 0 for this condition at which the change from lower surface to upper surface occurs. Are you with me?
Yes, sir.
Now is it easy to find out M? Yes. Now you can apply summation fx, summation fy, all those things. But wise thing to do is only M is asked. So you take summation of moments about A equal to 0. Are you with me?
Yes, sir.
Summation of moments of all the forces about Z axis passing through A equal to 0. That is going to give me what? Moment of HA and VA is 0. Moment of this force कितना आएगा बोलो?
Half into
3
3 into 400
into
2.
Into 2. And what is the sign?
Anti-clockwise.
No.
So minus.
No, it is clockwise. At about about A, isn't it clockwise?
Yes, sir.
And clockwise is negative. Happy?
Yes.
Then what is the moment of this 400 into 3? 400
Into 3 into
3 into 3.5. 3.5.
Yes.
You are taking moment about A.
Yes, sir.
Chaturthi, are you by chance from Mumbai?
No, sir.
Okay, I thought it is the local, that is local song. Anyway, so 400 into 3 into 3.5. So how much is that?
Minus.
Minus, because it is anti-clockwise. Then what is the sign of this M? Plus, because
Plus.
it is anti-clockwise. And moment can be transferred as it is anywhere in its plane. Happy?
Yes, sir.
And this is equal to 0. There will be no moment from RB because RB itself is 0.
Yes, sir.
So now solve this. Tell me the value of M.
So it is 5,400.
5,400. What will be the unit? Unit will be unit of force multiplied by unit of distance. So unit of force that we are using is pound. Unit of distance that we are using is feet. So it is 5,400 pound feet. This is the unit. And it is in which direction? Anti-clockwise direction. Are you with me?
Yes, sir.
So at this moment, if you slightly increase the moment beyond 5400, the upper roller will come in picture. If you slightly decrease the moment below 5400, the lower roller will come into the picture to maintain the equilibrium. Are you with me?
Yes, sir.
Okay. So this was quite tricky problem. The trick was you have to understand that when the contact is being changed from lower roller to upper roller, at that time, RB has to vanish. It has to be 0. Are you with me?
Yes, sir.
Okay. Now, Chaturthi, you can mute yourself now. And I would request now Muskan to unmute herself. I have sent the request. Please accept it. Muskan?
Yes, sir.
Yes. So let us go ahead now. This is the last problem in the series of equilibrium of beams. We will do few more problems, but those we will do side by side as we go on continuing with dynamics. Okay? Muskan?
Yes, sir.
Okay. So now determine the reactions at A and B of the inclined beam subjected to vertical load distribution as shown. Are you with me?
Yes, sir.
The load is vertical and it is uniformly varying load. Do you agree with me?
Yes, sir.
Uniformly varying load. The value of load distribution at right end of the beam is 5 kilonewton per horizontal meter. So per inclined meter नहीं दिया है, per horizontal meter. Are you with me? Are you with me? Muskan? Hello? Muskan? Have I lost? Am I audible to you? Please chat box में type
Yes, sir.
करो.
Sir, you are audible.
Okay, who is this? Mokshat. Hello?
Yeah.
Who was responding?
Sir, Mokshat.
Mokshat, please keep yourself unmuted till Muskan gets her audio back. Are you with me?
Yes, sir.
Okay. So now what is the meaning of 5 kilonewton per horizontal meter? Means if you travel horizontally 1 meter, that means you are going to travel some different distance in an inclined way. Are you with me?
Yes, sir.
So if you travel horizontally 1 meter, that means more than 1 meter in an inclined way, then you are going to get 5 kilonewton. This is what is the meaning of 5 kilonewton per horizontal meter. Are you with me?
Yes, sir.
Okay. So that's what is given. Now, Moksha, tell me what kind of reactions, what kind of support prevails at B?
Hinge support.
Hinge support. So कौन से तरीके के reaction रहेंगे?
Two support, vertical and
हाँ. So now,
horizontal with respect to hinge.
so now we will tend to show the reactions in this fashion. Do you agree with me? These are at 90 degrees to each other. One along the beam and one across the beam, perpendicular to the beam. Do you agree?
Yes, sir.
But even if I choose another set of orthogonal directions passing from the point, still these two can be resolved into those directions, and I can convert these reactions into the reactions along this horizontal and vertical direction. Do you agree with me?
Yes, sir.
So I am going to call this direction as X, this as Y. So even at B, I can still show the reactions as HA and VA. Are you with me? Mokshat?
Sir, yes.
Hello?
Yes, sir.
Should I repeat?
Yes, sir.
Okay.
Yes, just
So देखो, yes. So I should have shown the reactions in this fashion. ऐसे लगता है हमें. And I should have called this reaction as, let us say R1 and this reaction as R2. Do you agree with me, Mokshat?
Yes, sir.
Now tell me, this R2 is perpendicular to the beam. So will it make angle of 30 degrees with vertical? Do you agree with me?
Yes, sir.
क्योंकि बीम ने हॉरिजॉन्टल के साथ किया हुआ एंगल 30 है. सो बीम को परपेंडिकुलर जो है दैट इज R2, इट विल मेक हॉरिजॉन्टल को परपेंडिकुलर वर्टिकल के साथ एंगल 30 डिग्री. एंगल बिटवीन द लाइंस इज सेम एज एंगल बिटवीन देयर परपेंडिकुलर्स. आर यू विथ मी?
Yes, sir.
Now can I resolve this R2 in two components along X and along Y? Yes. R2 sin X is its X component and R2 cos X cos 30 is its Y component. Do you agree with me?
Yes, sir.
Similarly, I will be able to resolve R1 minus R1 cos 30 will be its horizontal component and R1 sin 30 will be its vertical component. Do you agree with me?
Yes, sir.
So if I add X components of R2 and R1, I will get HA. If I add Y components of R2 and R1, I will get VA.
Yes, sir.
Agree with me. So it is not necessary that I should stick to showing reactions in this fashion. I can choose any two perpendicular directions and I can show the reaction in those directions for a hinge support. Are you with me?
Yes, sir.
हाँ, so hinge support के लिए तो मैं HA और VA ऐसे दो रिएक्शंस दिखा सकता हूँ. What about roller support at A? वहां पे रिएक्शन कैसे होगा बताओ मुक्षित.
So, in two
हाँ,
direction.
it is going to be only in this direction. Do you agree with me? And I am going to call it as RA.
Yes, sir.
हैप्पी. हाँ, तो अब जरा देखो यहाँ पे मैं उसको एच और वी जैसे सॉरी इसको एच बी और वी बी को कहना चाहिए. आई एम सॉरी. आर यू विथ मी?
Yes, sir.
हाँ, इसको भी एच और वी दिखा सकता हूँ बट देन इट विल इंट्रोड्यूस द एक्स्ट्रा अननोन. हाउएवर एच एंड वी देयर विल बी इन टर्म्स ऑफ आर एंड 30 डिग्री. आर यू विथ मी?
Yes, sir.
हाँ, सो वैसे भी कर सकता हूँ बट आई प्रेफर टू शो इट दिस वे. नाउ कैन वी ड्रॉ फ्री बॉडी डायग्राम ऑफ दिस बीम? कैसे दिखेगा फ्री बॉडी डायग्राम बताओ. दिस इज द इंक्लाइंड बीम. आर यू विथ मी?
Yes, sir.
And it is subjected to uniformly distributed load of this nature, where this is 5 kilonewton per meter. Do you agree with me?
Yes, sir.
There is one reaction here and that is RA. Okay.
Yes, sir.
Now what is the angle that RA makes with vertical?
With RA?
RA makes with vertical
30 degree.
30 डिग्री. यस. कैसे किया ये हमेशा ध्यान में रखना. दिस इज ज्योमेट्री का 1 मिनट. दिस इज द ज्योमेट्री. देखो RA is perpendicular to beam. Do you agree with me? And this vertical direction is perpendicular to horizontal. Beam ने horizontal के साथ किया हुआ एंगल जो कि 30 डिग्रीज है, तो horizontal को perpendicular direction vertical ने beam को perpendicular direction RA के साथ किया हुआ एंगल भी 30 डिग्री होगा. Angle between the lines is same as angle between their perpendiculars. Are you with me?
Yes, sir.
हाँ, so ये हुआ 30 डिग्री. And now can we replace this UVL by a single force? इस UVL को एक सिंगल फोर्स से रिप्लेस कर सकते हैं. हाँ, कर सकते हैं. कैसे करेंगे? What will be the single force? That single force, जरा देखो यहाँ पे, that single force, चलो वो कितना होगा? हाफ बेस इनटू हाइट. डू यू एग्री विथ मी?
Yes.
हाँ, लेकिन अब ये बेस तो कैलकुलेट करना पड़ेगा हमें.
Yes, sir.
Agree with me? So what is this distance? Can you tell me how much is this distance? This total distance? It is 4 because this distance is 4. 4. This angle is also 30 degree.
Yes, sir.
So it is 4 cos 30. Do you agree with me?
Yes, sir.
So this total distance is 4 cos 30. Happy?
Yes.
So how much is this force? Half base, that is 4 cos 30, into height, that is 5 kilonewton per meter. Are you with me?
Yes, sir.
And where does it act? It acts at the centroid of this triangle. If this total distance is 4 cos 30 from vertex, what is this distance?
2/3.
2/3 of 4 cos 30.
Yes, sir.
You agree with me?
Yes, sir.
ये डिस्टेंस भी दिखा दिया. So now what is the equivalent diagram? चलो equivalent diagram दिखाता हूँ. This is RA free body diagram which makes an angle of 30 degrees with vertical. Happy?
Yes, sir.
Then you are going to have HA and VA. तो ये ऐसे दिखा है HA and VA, HB and VB.
Yes,
Do you
sir.
agree with me? And I have shown this force which is half 4 cos 30 into 5 which acts at a horizontal distance of 2/3 of 4 cos 30.
Yes, sir.
2/3 of 4 cos 30. And what is this total horizontal distance? Total horizontal distance is 4 cos 30. Happy?
Yes, sir.
4 cos 30. Happy?
Yes, sir.
हाँ, चलो तो अब कैसे करेंगे now? First thing that we are going to do is to get this RB, to get this RA. What I am going to do is I am going to take moment about B equal to 0. Are you with me?
Yes.
Summation of moments of all the forces about Z axis passing through B equal to 0. Quickly tell me what is the moment. What will be the moment of this force? It is vertical force. Do you agree with me?
Yes, sir.
It causes anti-clockwise movement, so plus.
Yes.
How?
Sir, clockwise, no?
No, at B we are taking the moment. This causes anti-clockwise moment.
So of RA?
No, we are writing down the moment of this force.
Okay, okay.
So
And
1/2 into 4 cos 30. Do you agree with me?
yes, sir.
Into 5. Distance कौन सा लेना है? तो
1/3.
वर्टिकल फोर्स को मैं इस पॉइंट से I have to draw perpendicular on this vertical line because line of action of this force is vertical and that is going to be 1/3 of 4 cos 30. Do you agree with me?
Yes, sir.
So it is 1/3 of 4 cos 30. Happy?
Yes, sir.
Now, what about this? Now, RA is perpendicular to this line itself. Do you agree with me?
Yes.
So, if I draw perpendicular from B on the line of action of RA, it is this distance itself, inclined distance itself. Are you with me?
Yes, sir.
So, RA का moment कितना आएगा? Minus RA into 4. Happy?
Yes.
You have to note this point very carefully. देखो ये vertical force का moment लेते वक्त मैंने क्या किया है? I have considered horizontal distance between point B and this force. Why? Because you have to draw perpendicular from point where you want to take the moment on line of action of force. Line of action of force is vertical. So वो जो perpendicular है वो रहने वाला है horizontal. So I am interested in this horizontal distance. This horizontal distance is 1/3 of 4 cos 30. So इस force का moment calculate करते समय 1/3 horizontal distance consider किया वो था 1/3 of 4 cos 30. That's why that is taken. Whereas you can understand RA is already perpendicular to points joining AB. Line joining points AB. Do you agree with me?
Yes, sir.
So it's moment about B. For that, I will have to draw perpendicular on line of action of RA from B, but that is the line AB itself. So what is the length AB? Length AB is 4 meter. So moment of RA is RA into 4 about B. Do you agree with me?
Yes, sir.
And it is clockwise. Therefore, I have taken it as negative. So therefore, this is equal to 0. So what is the value of RA? Tell me. Calculate and tell me.
Just a second.
Ensure that your calculator is in degree mode. It is going to be half into 4 cos 30 into 5 into 1/3 of 4 cos 30. This entire thing divided by 4.
Yes, sir. Just a second. So 10 divided by 4, 5 by 2.
So it turns out to be 2.5. I also got the same answers. Is it right?
Yes, sir.
So 2.5. What should I say? Kilonewton. Look at the units. All units are given in kilonewton per meter. So force is in kilonewton. So 2.5 kilonewton. Originally assumed sense of RA must be correct as it is positive. Do you agree with me?
Yes, sir.
So RA कैसे दिखाना है? ऐसे दिखाना है देखो. This is point A. At point A, RA is pushing because originally assumed sense is correct and it makes an angle of 30 degrees with the vertical. ये सारी चीजें आनी चाहिए. Are you with me?
Yes, sir.
This is the answer. Now, how do I get? What else to be found out? I need to find out HA and VB. Do you agree with me?
Yes, sir.
Now, summation Fx equal to 0 will give me what? Now HB will not be 0. देखो, RA sin 30 is the horizontal component of RA. Do you agree with me?
Yes, sir.
And it is positive because RA is, so you can see its component is positive. RA sin 30. Happy?
Yes, sir.
But what is RA? RA is 2.5. So I will substitute 2.5 times with sign substitute करना. अगर यहाँ पे RA minus आता तो यहाँ पे minus substitute करता. Are you with me?
Yes, sir.
So RA 2.5 sin 30. दूसरा कोई component है? No, all these force is vertical, so it has no horizontal component. Only VB doesn't have horizontal component. So plus HB. Why? Because I assumed HB towards right. Do you agree with me?
Yes, sir.
And this must be equal to 0. Do you agree with me?
Yes, sir.
This implies HB is equal to what?
Negative
Minus 2.5 sin 30. Tell me how much is that?
2.5 divided by 2. 1.25.
Minus 1.25 kilonewton. So what is the meaning of negative sign? Negative sign means that originally assumed sense of HB is incorrect and HB has to be towards left. Are you with me?
Yes, sir.
Towards left. Now let me tell you one point of question here. यहाँ पे हम दिखाएंगे कि therefore it is towards left. But अगर समझो आपको बाद में एक equilibrium equation use करना है और आपको HB use करना है, तो HB को right hand side में लेके ही उसका sign दो. While substituting the value of HB, you will automatically substitute negative sign. Are you with me?
Yes, sir.
So we have shown it towards left, but if in further calculation HB is needed, decide its sign only as per the assumed free body diagram. एक बार free body diagram बनाया तो उसके ऊपर के सेंस, मतलब पत्थर के, काले पत्थर के ऊपर की सफेद लकीर, उसको चेंज नहीं करेंगे. We will only substitute it as negative. Are you with me?
Yes, sir.
Okay. चलो. Now how do we find out VA? चलो. Summation Fy equal to 0.
Yes, sir.
चलो. Tell me what is summation Fy. So summation Fy में RA का vertical component आएगा. So it is going to be RA cos 30.
Yes.
Happy? जिसके बीच में थीटा वो एंगल cos थीटा. So RA is 2.5 plus 2.5. So I will put it as plus. अगर ये नेगेटिव रहता तो इधर नेगेटिव बोलता. But I would not have changed the sense of RA in the original diagram. वो वैसे ही रखना है. जो साइन आएगा वो साइन सब्स्टिट्यूट करो. Are you with me?
Yes, sir.
चलो. RA cos 30. Then minus half into 4 into cos 30 into 5. Do you agree with me?
Yes, sir.
Minus half into 4 into cos 30 by cos 30 into 5. Happy?
Yes, sir.
ये हुआ डाउनवर्ड फोर्स एंड प्लस VB.
Yes.
HB का तो कोई कंपोनेंट आएगा नहीं. दिस मस्ट बी इक्वल टू 0. सो हाउ मच इज VB? टेल मी. VB is going to be half into 4 into cos 30 into 5 minus 2.5 cos 30.
Sir, 3.75 cos root 3. Sorry.
No. Tell me number.
So 6.5.
6 point. Yeah, I am also getting this. So 6.5 kilonewton and positive आया. तो positive आया का इसका मतलब क्या है? Originally assumed sense is correct. Therefore it is upward.
Yes.
Are you with me?
Yes, sir.
So we have found out all the reactions for this beam. So आज के सारे problems में कुछ ना कुछ trick था. So you have to. I hope you have understood everything. And now today's class we are almost at the end, but we will begin with dynamics. चलो dynamics का श्री गणेशा कर देते हैं. Then from tomorrow's class onwards, we will discuss the dynamics. So I will just toss few terms in dynamics and then we will stop for today. Are you with me?
Yes, sir.
Dynamics. So dynamics के दो branches है. One is statics and one is kinetics and another is kinematics. Are you aware of this?
Yes, sir.
So can you tell me what is kinetics and what is kinematics? बोलो. Mukshad? Mukshad, are you there? Am I audible?
Yes, sir. Sir, am I audible?
Hi. Yes, you are audible now. So what is difference between kinetics and kinematics?
Kinematics is a description for a point.
Pardon?
So motion of points, objects, kinematics.
And then what is kinetics?
Uh,
Mukshad, I lost your voice. Okay, so in this last segment, let me go back to Muskan. Muskan, can you unmute yourself? Muskan?
Yes, sir.
Yes.
Am
So
I
what do you
audible?
think? Yeah, you are audible. What is the difference between kinetics and kinematics? Are you with me?
Yes, sir.
Okay. So you don't know? Just tell it. We will go ahead.
In
Muskan?
kinetics,
Huh.
we deal with uniform motion, and in kinematics, we have non-uniform motion.
No, nothing of that sort. So let me first tell you what is the difference between kinetics and kinematics. For that, this difference I will spell in the next class. But for that, let me ask you a fundamental question. What causes the motion? Tell me. As we are dealing with dynamics, we are dealing with the objects which are moving. So now tell me what causes the motion. Yes, Muskan.
Force.
Okay. So the motion is caused by a force. That's what we will say. Are you with me?
Yes, sir.
Force. Okay. And now tell me, typically, what is involved in generation of a force? Okay, so as we have ventured 5 minutes in your recess time, I think we should stop here. What we will do is, I have raised two questions. What causes the motion and what is kinetics and kinematics? The entire class will think on it and you are going to give me the versions of your understanding about all these terms in tomorrow's class. And then we will continue from there. Okay, Muskan? So the class now can write down your roll number and name in chat box and you can leave the meeting. If anyone has doubt, you can raise your hand or you can type it out, you can type in chat box. I will unmute you and then you can ask the doubt.